Okay, for 74, they want values of A and B that make it true. Again, let's just see what happens here. So I have 6 equals A times B to the 0, right? But B to the 0 is 1, right? So I really have 6 equals A for that first equation. So I solved for A. Now the second equation is 24 equals A times B squared. We know A is 6, so I have 24 equals 6B squared. Divide by 6, I get 4 equals B squared. And if I take the square root, B comes out to be 2. Or negative 2, right? Because it could be either. So I would say that A equals 6 and B equals, plus or minus 2, right? But they really only asked for a value of A or B. They didn't ask for everyone, although then they said solve each system. So I'd say A is 6, B is plus or minus 2, and that would work in both those equations. And then B, let's do B. Let's make space. For B, we have the two equations, and I'm going to solve each one for A, right? So the first one becomes 32 over B squared equals A. And the second one becomes 128 over B cubed equals A. Now I'll use equal value methods. Since they both equal A, then they both equal themselves. So let's put that here. 32 over B squared equals 128 over B cubed. And now we cross multiply, right? That's one thing we could do. We get 32 B cubed equals 128 B squared. We can divide both sides by B squared, right? So divided by B squared, divided by B squared. And we get 32B equals 128, right? Those B squareds cancel. And we divide by 32, and we get B equals 4. And now we have to substitute into one of them to get A, right? So let's do that up here. Let's do 32 equals AB squared. So 32 equals A times 4 squared, right? So 32 equals A times 16. Divide by 16. So we get A is 2. So I would say A is 2. B is 4 for part B.